Today we're going to be continuing with our exact first order differential equations. In yesterday's video I got a few comments afterwards saying that the way that other people had been taught this was different from the way I explained it. So I'm going to do the other method today. Both are equally valid, but just to explain how they both work. This is the solution here where that psi of xy equals c some constant, and we can rewrite psi as some function of f of xy add g of y add h of x. Okay, now the total, this is called the total differential. Okay, the total differential dt is equal to the partial derivative d psi dx add the partial derivative d psi dy. Okay, and what we do is we call d psi dx m of xy and we call d psi dy n of xy. Okay, now what we do when we test for an exact equation is we differentiate that one partially with respect to y, which is my, or dm dy, and we check to make sure that it's equal to the partial differentiation of that one with respect to x, which is dn dx. And the reason why those two have got to be equal is because that one would be d psi dx dy of that, and this one here would be d psi dy dx of that, and the second derivative of psi with respect to x and y is the same if it's exact. So that's why it works, and that's what we're trying to do. Okay, now in the previous video what we did was we integrated this m here with respect to x, which got us back up to part of this, namely that bit and that bit, and then we integrated n, and that got us again that bit and that bit when we integrated it with respect to y. Okay, now what we're going to do today is what happens if one of these integrations is easy and the other one is difficult. Well, let's imagine that m is the easy one. When we integrate that, we will get f of xy and h of y, but the g of y we will have to work out, because when we differentiated this partially with respect to x to get mxy, this g of y would have cancelled out, and that is why later on we have to work out what it is. Ditto, if n was the easy integration, we would have got fxy add g of y, and we would have to then work out what h of x was, because h of x would have been the one that dropped out when we did the partial differentiation of psi with respect to y. Okay, so with all of that sorted out, hope that's clarified stuff. Let's get on to the question in hand. Okay, so here is the actual question. We have to solve this rather horrific looking thing, and we have an initial condition here. Okay, well, step one, the first thing we need to do is we need to put it in the form of mxy dx add nxy dy equals 0. Okay, so let's do that now. So that would be y cubed e to the xy minus 2 dx, add, all I'm doing is I'm moving everything across, 2y e to the xy add xy squared e to the xy dy equals 0, and this here is our m and this here is our n. All I've done is I've just moved all of that across and collected everything up. Okay, and then the next step is we have to check that the partial derivative of m with respect to y is the same as partial derivative of n with respect to x. So what we need to do is we need to differentiate that, and we need with respect to y, and we need to differentiate that with respect to x. Okay, so let's do that. Okay, so dm dy is equal to 3y squared, just using the product rule, e to the xy add y cubed x e to the xy. Okay, and dn dx equals 2y squared e to the xy. Sorry, it's off the screen, the thing. You'll have to just scroll up. Xy squared y e to the xy add y squared e to the xy, and adding all that up gives us 3y squared e to the xy add xy cubed e to the xy, which is the same as that, so therefore dm dy is equal to dn dx, and therefore we know it's an exact equation. Phew. Okay, so now what we want to do is we want to integrate the easiest. Okay, well, if we look at this, we have to integrate that with respect to x, which is quite easy, or we need to integrate that with respect to y, which is not easy. So what we're going to do is we're going to integrate m with respect to x, and that is going to give us a g of y, which we then have to work out. Okay, so step 3, integrate the easiest. Okay, well, the easiest is clearly m. So we're going to we're going to integrate m xy dx, and m was what was m? Sorry. Where was it? Y cubed e to the x squared. Yep. So we have to. That equals the integral of y cubed e to the xy minus 2 dx. Okay, and we're integrating that, so that will be y cubed e to the xy over y minus 2x, add g of y, which we've already discussed. Okay, and that will be equal to psi of x, y. Okay, but we still need to find g of y, and that will cancel there, so that will give y squared e to the xy minus 2x dx. Okay, and that we still need to add g of y, but we still need to find what g of y is. So what we do now, because we're only going to do one of the integrals instead of two, what we need to do now is we need to differentiate psi that we just found and equate it to m or n to find g dashed or h dashed, and hence we can find what it is. Okay, so let's now differentiate psi with respect to y, which we know is going to be equal to n xy by definition, equals, and what was the thing again? It was y squared e to the xy minus, let's just rewrite that, so that will be equals 2y e to the xy, I'm differentiating it now, add xy squared e to the xy, okay, and that equals 2y e to the xy, add y squared x e to the xy, add g dashed of y, and that bit there is n, and that bit is the differential that we just found. So if we just compare these two, we can see that g dashed of y must therefore equal 0. So we know that g dashed of y equals 0, so therefore g of y must be some constant. Okay, so now we know that psi of x and y must be equal to y squared e to the xy minus 2x, add some constant. That is our implicit solution. Okay, now we know that to find the initial conditions, to find our constant, well, we know that y of 0 was 1. We were given that in the question. And so therefore, just putting x equals 0 and y equals 1 into that, we get that c equals minus 1. And so therefore, we have our implicit solution is y squared e to the xy minus 2x equals 1. And that is the answer to the question. Okay, so you can do it by only integrating 1 if you want to. Now, let's do a step 6. This is a bonus step here. You don't have to do it. Let's differentiate that with implicit differentiation to see if we get back where we started. Okay, so let's do this by using the product rule. Okay, so that will be, we're going to differentiate with respect to x. So that will be 2y dy dx, using implicit differentiation, e to the xy, add y squared, and we'll deal with this bit in a minute, e to the xy dx minus 2 equals 0. Okay, so let's just have a look at this bit here. Well, differentiating e to the xy, let's let xy equal u, and therefore x du dy dx add y equals du dx. We're going to use the chain rule here. So therefore we know that 2y dy dx times by e to the xy add y squared times e to the xy x dy dx add y minus 2 equals 0. And all we need to do now is just collect all of this up. That's 2y dy dx e to the xy, add y squared e to the xy x dy dx, add y cubed e to the xy minus 2 equals 0. And all we need to do now is just put those in the right form. That'll be y cubed e to the xy minus 2 dx, which is that lot dx, add 2y e to the xy, add y squared e to the xy times x dy equals 0. And hence we have shown that the solution that we had here, when we actually differentiate it, we do get back to our first order differential equation. Okay, well, I hope you found this useful. If you have, please like this video by pressing the little thumbs up button and subscribe to the Gresty Academy YouTube channel.